Welcome to Senior High School Math Series. In this video presentation, let us discuss about the definition and equation of a hyperbola with center at HK. This is under pre-calculus. Here are our learning competencies. Identify the equation of the hyperbola with center at HK. Determine the properties of the hyperbola with center at HK. Before we continue, let us ponder on this. Take fast hold of instruction. Let her not go. Keep her, for she is thy life. This is from Proverbs chapter 4, verse 13 of the King James Bible. This time, let us have a recall of some important concepts. A hyperbola is the set of points P in a plane such that the difference of the distances of each point P of the set from two fixed points in the plane is a constant. Prior to this video lesson, we derived the equation of a hyperbola, and we discussed about the hyperbola with center at the origin. If you haven't seen it, the link is on the description of this video. During the discussion of the hyperbola with center at the origin, we learned that if the equation is given by x squared over a squared minus y squared over b squared equals 1, the transverse axis is along the x-axis. The center is at 0, 0, that is the origin. A focus is a units away from the center, hence the foci have coordinates positive, negative, c, 0. A vertex is a units away from the center, hence the vertices have coordinates positive, negative, a, 0. And since the hyperbola has asymptotes, the equation of the asymptotes are y is equal to positive negative b over a x. Also, when the equation of the hyperbola is given by y squared over a squared minus x squared over b squared equals 1, the transverse axis is along the y-axis, the center is still at the origin, 0, 0, and the foci have coordinates 0, positive, negative, c. The vertices have coordinates 0, positive, negative, a. And the equation of the asymptotes is given by y is equal to positive, negative, a over bx. In here, the relationship between c, a, and b is given by c squared is equal to a squared plus b squared. This time, let us proceed to the hyperbola with center at HK. If a hyperbola with center at the origin and transverse axis along a coordinate axis is shifted h units horizontally and k units vertically, the result is a hyperbola with center HK. The equation of such hyperbolas have the same forms as the equation of the hyperbolas with center at the origin, except that x is replaced with x minus h and y by y minus k. So we have a hyperbola with center with coordinates hk. The vertices v prime and v are each a units away from the center. Hence, the coordinates of v prime and v are h minus ak and h plus ak respectively. The segment joining V prime and V is what we call the transverse axis. It is of length 2A. The conjugate axis is a segment of length 2B, and it is perpendicular to the line containing the vertices with center as the point of perpendicularity. The endpoints of the conjugate axis are each B units away from the center. Collinear with the vertices and the center are the foci, F prime and F, which are each C units away from the center. Hence, the coordinates of F prime and F are H minus CK and H plus CK respectively. The segment through the focus with endpoints at the hyperbola is what we call the latus rectum. The latus rectum is of length 2b squared over a, and the ends of latus rectum has coordinates h minus c k plus b squared over a and h minus c k minus b squared over a. The other two endpoints of the latus rectum have coordinates h plus c k plus b squared over a. The other one, h plus c k minus b squared over a. The asymptotes of the hyperbola may be located by first drawing an imaginary rectangle passing through the vertices and the co-vertices of the hyperbola. The asymptotes are those lines containing the diagonals of this imaginary rectangle. And the equation of these asymptotes are given by y minus k equals plus minus b over a quantity x minus h. This time, let us proceed to the hyperbola with center at hk and whose transverse axis is parallel to the y-axis. The equation is given by y minus k squared over a squared minus x minus h squared over b squared equals 1. The center is with coordinates hk. Collinear with the center are the vertices, and this has coordinates v. Since a vertex is a units away from the center, then v has coordinates h, k plus a. The other one, v prime, is with coordinates h, k minus a. The transverse axis is now parallel to the y-axis and still it is 2a units. The conjugate axis, which is perpendicular to the line containing the vertices and the center is the point of perpendicularity, is still 2b units of length, and the endpoints are the co-vertices, which are each b units away from the center. Collinear with the vertices and the center are the foci of the hyperbola. And since a focus is c units away from the center, then the coordinates of f will be h, k plus c, and f prime will be h, k minus c. The latus rectum is still of length 2b squared over a. Notice that the latus rectum, when the hyperbola has its transverse axis parallel to the y-axis, the latus rectum are parallel to the conjugate axis. Also, the latus rectum is perpendicular to the line containing the focus, the vertices, and the center, with each of the foci as the point of perpendicularity. The ends of latus rectum will have the coordinates h minus b squared over a, k plus c. Then we have h plus b squared over a, k plus c. On the other branch of the hyperbola, the ends of latus rectum will have the coordinates h minus b squared over a, k minus c. And the other one, h plus b squared over a, k minus c. To locate the asymptotes of the hyperbola, we draw the imaginary rectangle passing through the vertices and the co-vertices of the hyperbola. The asymptotes are those imaginary lines passing through the diagonals of this imaginary rectangle. The equation of the asymptotes will be y minus k equals positive negative a over b x minus h. This time, let us have some examples. Example number 1. Draw the graph of 12y squared minus 4x squared plus 72y plus 16x plus 44 equals 0. Here is our suggested solution. For us to graph the hyperbola, we need to rewrite the equation in its standard form. So we will start with the given equation. 12y squared minus 4x squared plus 72y plus 16x plus 44 is equal to 0. From here, we are going to form two perfect square trinomials in y and x. So we're going to rearrange the equation so that we have 12y squared plus 72y minus 4x squared plus 16x, and then subtract 44 from both sides of the equation so that on the right hand side we will have negative 44. Next, we have 12 times the quantity y squared plus 6y, close quantity, minus 4 times the quantity x squared minus 4x, close quantity, equals negative 44. So we are now ready to complete the square in each group of variables. Y squared plus 6y, we have 6 over 2, that is 3, and the square of 3 is 9. So inside the parentheses, to make this a perfect square trinomial, we add 9. In a way, we are adding 12 times 9 to the left-hand side of the equation, and that is 108. We also need to add 108 to the right-hand side of the equation. For the other variable, x squared minus 4x, we're going to turn this into a perfect square trinomial. So we have negative 4 divided by 2, that's negative 2. The square of that is positive 4. And in effect, we have subtracted 4 times 4 to the left-hand side of the equation. Because negative 4 times 4 is negative 16, we will also subtract 16 to the right-hand side of the equation. This time, we're going to simplify the equation so that we will have 12 times factors of y squared plus 6y plus 9 and x squared minus 4x plus 4. We have y plus 3 squared and x minus 2 squared, respectively. In the standard form of the equation of the hyperbola, the right-hand side is equal to 1. Hence, from this resulting equation, we will divide both sides by 48 so that we will have y plus 3 squared over 4. that is 12 over 48, 1/4, minus x minus 2 squared over 12, that is 4 over 48, 1 over 12. And on the right-hand side, 48 over 48 is equal to 1. From the standard form of the equation of the hyperbola, y plus 3 squared over 4 minus x minus 2 squared over 12 equals 1, we're going to graph the hyperbola. Let us have the y-axis and the x-axis. From the equation, notice that the center is at 2, negative 3. Hence, h is equal to 2 and k is equal to negative 3. Also from the equation, in the positive term, a squared is equal to 4, then a is equal to 2. So we have a vertex that is 2 units away from the center, and this will have coordinates 2, negative 1. Also, a vertex that will be 2 units away from the center will have the coordinates 2, negative 5. Going back to the equation, b squared is equal to 12, then b is equal to 2 square root of 3. Notice that in the standard form of the equation of the hyperbola, the positive term is y plus 3 squared over 4. So we have the transverse axis that is parallel to the y-axis. And since b is equal to 2 square root of 3, we have the conjugate axis whose endpoints are each 2 square root of 3 units away from the center. Then we're going to draw the imaginary rectangle to locate the asymptotes of this hyperbola. And then we will draw the branches of the hyperbola, one that is opening upwards and the other that is opening downwards. And if we're going to locate the foci, this will be collinear with the vertices and the center. And since a squared is equal to 4 and b squared is equal to 12, we have c squared is equal to 16. And from here, getting the square root of both sides, c is equal to 4. So a focus is 4 units away from the center going up and 4 units away from the center going down. The foci will have the coordinates 2, 1 and 2, negative 7. Example number 2. Identify the properties of the hyperbola x minus 1 squared over 16 minus y plus 2 squared over 9 equals 1. From the given equation, we can readily identify the coordinates of the center. That is 1, negative 2. And before we can identify the other properties, let us find the values of a, b, and c. X minus 1 squared over 16 is the positive term. Then we have the hyperbola whose transverse axis is parallel to the x-axis. So we have a squared is equal to 16. Getting the square root of both sides, a is equal to 4. Also, we have b squared is equal to 9. Then b is equal to 3, getting the square root of both sides. C squared is the sum of a squared and b squared. So we have c squared is equal to 16 plus 9, 25. Getting the square root of both sides, c is equal to 5. And then from here, we will identify the properties of the hyperbola. Since the transverse axis is parallel to the x-axis, then the vertices will be 4 units away from the center. One of the vertex will be 1 minus 4, that's negative 3, negative 2. And the other will be 1 plus 4, that will be 5, negative 2. The transverse axis is of length 2a, so we have 8. The conjugate axis is of length 2b, so we have 6 for the conjugate axis. The foci are collinear with the vertices and the center, and it is c units away from the center. So we have 1 minus 5, that will be negative 4, negative 2. And the other one will be 1 plus 5, 6, negative 2. The latus rectum is of length 2b squared over a, so that will be 2 times 9, 18 over 4, simplified as 9 over 2. This time, let us identify the ends of latus rectum. Since the transverse axis is parallel to the x-axis, the ends of the latus rectum will have the same x-coordinates as the foci. Let's have the ends of the latus rectum that is collinear with negative 4, negative 2. So we have negative 4, the y-coordinate will be negative 2 plus b squared over a, that is 9 over 4. So negative 2 plus 9 over 4 is 1/4. And the other one will have negative 4. The y-coordinate will be negative 2 minus 9 over 4, and that is negative 17 over 4. On the other branch of the hyperbola, the ends of the latus rectum will have the same x-coordinates as the other focus. So we have 6, and then negative 2 plus 9 over 4, that is 6, 1/4. The other one is 6, negative 2 minus 9 over 4, negative 17 over 4. Let us proceed to the equation of the asymptotes. We have y plus 2 equals positive negative 3 over 4, that is b over a, times the quantity x minus 1. Let us have example number 3. Find the equation of the hyperbola with center at 1, negative 2, transverse axis parallel to the x-axis, transverse axis of length 6, and conjugate axis of length 10. Here is our suggested solution. Since the transverse axis is parallel to the x-axis, we're going to use the standard form of the equation x minus h squared over a squared minus y minus k squared over b squared is equal to 1. To find the equation of the hyperbola, we need to identify the values of h, k, a, and b. Then substitute this to the standard form of the equation. It is known that the center is at 1, negative 2, then h is equal to 1, and k is equal to negative 2. Also, the transverse axis is of length 6, then 2a is equal to 6. Dividing both sides by 2, we will get a is equal to 3. Another information is that the conjugate axis is of length 10, then 2b is equal to 10. Dividing both sides by 2, we will get b is equal to 5. Now we're going to substitute h equals 1, k equals negative 2, a equals 3, and b equals 5 to the standard form of the equation of the hyperbola. Thus, we will get x minus 1 squared over 9 minus y plus 2 squared over 25 equals 1. Let us have example number 4. Find the equation of the hyperbola with center negative 3, 2, transverse axis parallel to the y-axis, passing through the point 1, negative 7, and the asymptotes are perpendicular to each other. Here is our suggested solution. Since the transverse axis is parallel to the y-axis, then we're going to use the standard form of the equation, y minus k squared over a squared minus x minus h squared over b squared equals 1. It is known that the center is at negative 3, 2, then h is equal to negative 3 and k is equal to 2. Another given, the asymptotes are perpendicular to each other. This implies that A is equal to B. Also, the hyperbola passes through the point 1, negative 7. Then, substituting x equals 1, y equals negative 7, h equals negative 3, and k equals 2. Also, substituting a equals b, we will have the equation negative 7 minus 2 squared over a squared minus 1 plus 3 squared over a squared equals 1. And from here, we will be able to get the value of a squared. Multiplying all terms of the equation by a squared and evaluating the numerators, we'll have negative 7 minus 2 squared, that is 81, minus 1 plus 3, that is 4 squared, 16. On the right-hand side, we will have a squared. So we have a squared is equal to 81 minus 16. And 81 minus 16 is 65. So a squared is 65, and also b squared is 65 since the asymptotes are perpendicular to each other. Hence, substituting h equals negative 3, k equals 2, and a squared equals b squared equals 65 to the standard form of the equation, we'll have our final answer as y minus 2 squared over 65 minus x plus 3 squared over 65 equals 1. One way to check whether our final answer is correct is to graph the equation of the hyperbola and check whether the properties are met. So let us graph y minus 2 squared over 65 minus x plus 3 squared over 65 equals 1. So let us use the Desmos to graph our equation and check whether it meets the requirements or the conditions in the problem. We have y minus 2 squared over 65 minus x plus 3 squared over 65 equals 1. Then we have a hyperbola with transverse axis parallel to the y-axis. And let us see if it passes through 1, negative 7. Then we have the point 1, negative 7 on the hyperbola. Also, let us check whether the center is at negative 3, 2. So we have the center at negative 3, 2. Then all the conditions given in the problem are met by the equation, so our answer is correct. That will be all. Thank you for watching. Please subscribe for more math lessons.